Welcome to this second section of the operations management series, and here we are talking about the forecasting techniques. In the earlier section we had talked about the importance of forecasting, we had talked about what is forecasting, we had talked about the qualitative methods of forecasting. Now in this section we are going to talk about the quantitative methods of forecasting techniques. So here the most popular and the most simpler way of forecasting techniques is time series. So in time series we assume that what has occurred in the past will continue to occur in the future. It relates the forecast to only one factor, which is time. So it includes methods like moving average method, exponential smoothing method, linear trend line. So time series means that based on the past demand, we are going to extrapolate it for the future. So again, I would like to draw an analogy with the equity markets, stock markets. In stock markets, there are two methods of analysis of the stock market. One is the fundamental analysis and the other one is the technical analysis. In the case of technical analysis, the future prediction of the share price is done based on the past data. So similarly in the businesses also we are going to predict the demand for the future based on the past demand of that product or that service. So we will see first of all the moving average thing. In moving average there are various kinds of ways. One is called NAV forecast, the other one is called simple moving average, then comes weighted moving average. NAV forecast, demand of the current period is used as next period's forecast. Simple moving average, stable demand with no pronounced behavioral patterns. Weighted moving average, weights are assigned to most recent data. So we'll see it through the numerical examples also, but here NAV forecast means it's a very simple forecast. So for example, let's say we are predicting for the month of July. So whatever is the demand for June, we say that for July also the demand will be the same as June. So demand of the current period is used as next period's forecast. Similarly for August, we want to predict, so whatever will be the demand for July, we will say it will be the demand for August. So it's a very, very simple and kind of a thumb rule kind of a system where we are forecasting. In simple moving average, we are saying that we will see the recent data of say last 3 months or maybe last 4 months, that is simple moving average. In weighted moving average, although we are taking the recent month's data, but we are putting weight the most recent. For example, today suppose the month is June, so we will say that we will put more weightage to June than to May, and less weightage to May, then even lesser weightage to April, and even lesser weightage to March. So like this. So let us see this example on the slide. For example, for the month of January, the orders per month have been 120, February 80, March 100, April. So like this you are seeing all these orders. So moving average, NAV approach. So whatever is the demand for January, we will say this is the forecast for February, that is 120. Whatever is has been the demand for February, we will say this is the forecast for March. Whatever is the demand for March, which is say 100, so that is the forecast for April. So this is the NAV approach. So very simple approach. Then we come to simple moving average. So moving average, MAN is equal to summation, that is sigma di upon n, where n is the number of periods in the moving average and di is the demand in period I. So here what you are doing, for example, you have said that I will take a simple moving average of past 3 months. So I will take the demand of past 3 months. Let's say you are predicting the demand for January. So you will take the past 3 months demand, that is December, November and October, and you will add the 3 demands that is summation, and then you will multiply it by, you will divide it by 3. So you will get the average of the past 3 months demand. So moving average is past 3 months demand. Now you want to predict for February. So now you will not take December, November and October. You will take January, December and November. So immediately preceding 3 months you will take, and you will take the average of the 3 months demand. So that is moving average. So let us see this through an example on the slide. So again we are saying for various months, these are the orders, actual orders per month. So moving average, sigma di upon 3. So we are taking here 3 months moving average. So this depends on you whether you want to take 3 months moving average, you want to take 4 months, or you want to take 5 months. So that depends on you, on the industry. So here they have taken 3 months average. So we want to predict for November, let's say. So November we have taken 90, which is for October, then 110, which is the demand for September, then 130, which is the demand for August. So we have added these 3 demands and then divided by 3. So the average comes to 110 orders. So for November, the forecast or the prediction is 110 orders. So this is a 3-month simple moving average. So it depends on the industry, as I said. In some industries, it is very important that last 3 months moving average should be taken. In some industries, it is important to have only just last 2 months are more important for them. So it will depend on industry to industry, product to product. So you have to understand the trend of your product. So therefore, we have worked out in this slide, if you see, we have worked out, the moving average for, let's say, April. So we have used the same formulas for April, for May, June, July, August, September, October and November. So like this, you can calculate the moving average for the next period. Similarly, as I said, you can take 3 months moving average, you can take 5 months simple moving average. So in 5 months simple moving average, you will take immediately preceding 5 months. So for example, if you see this example, so same formula, MA, that is moving average, is equal to sigma di, and sigma is I from 1 to 5. So for you want to predict the demand for November, so you have taken the last 5 months actual orders and you have divided by 5. So which comes out to 91 orders for November. And similarly, you can calculate on a moving average demand for other months also. So this is how you calculate the simple moving average thing. So this is quite simple. So basically, what happens that then you have to compare. First of all, you have forecasted, and when the actual month comes, so you get the actual demand. So then you have to compare also, and you have to see where was the deviation. So for example, if you see this slide, the curve you have seen, the actual demand has been like this. So there has been a huge, there has been a huge, you can say, spike in the demand. Spike in the sense that the demand has shown a very downward trend, and it is a very high downward trend. So smoothing effects, what happens in forecasting when you do a simple average, like 3 months or 5 months, it tries to smoothen out these actual variations. So for example, this is a 3 month in blue line, this is kind of smoothing. When you take 5 months, so it further smoothens it out. So that is why the more months you take, the more it will smoothen out the variations. Then we have the third method, which is called weighted moving average method. So weighted moving average method, it's further refinement to the simple moving average method. So basically here you are giving weightage, more weightage to the more recent demand, because that is more relevant to the business, and less weightage to the previous months. So here we use a formula that WMA, that is weighted moving average, is equal to summation, that is sigma WI DI, where WI is the weight or weightage for period I. It can be between 0% to 100%, or in other words we take weightage as 1, and DI is the demand for that particular period. So what we are giving, we are giving a weightage to that particular month. So for example, here as an illustration we have taken 3 months, August, September, October. For August, we have given means this particular business has given 17% weightage to August, 33% weightage to September, and 50% weightage to October, and they are doing the forecast for November. So definitely they are giving more weightage to the immediately preceding month, which is October, then lesser weightage to September, and much lesser weightage to August. And this is the data which is the demand, which has been the demand for these respective months. So November forecast will that is weighted moving average will be sigma Wi Di, that is Wi weightage for October is 50%, so you will write 0.5, and demand is 90 for the month of October, plus weightage for September, which is 0.33 into the demand for September, which is 110, plus weightage for August, which is 0.17, that is 17%, into the demand, which is 130. So when you calculate this, it comes to 103.4 orders. So this is the forecast for the November month. So therefore this is a further refinement to the simple moving average. So here the curve which we saw earlier, it will further smoothen out. Then we have another method, we have further better method, which is further refinement of the weightage moving average method, which is known as exponential smoothing method. In exponential smoothing method, basically we further average down and we use a smoothing constant, and definitely it also weighs the most recent data more strongly. It is also reacting more to the recent changes, and it is a more accurate method than the earlier methods. So what is the formula for this exponential smoothing method? The formula for this method is ft plus 1, that is the next period, t plus 1 means the next time period, is equal to alpha into dt plus 1 minus alpha into ft, where ft plus 1 is the forecast for the next period, dt is the actual demand for the present period, ft is the previously determined forecast for present period, and alpha is the weighting factor, or it's the smoothing constant. Now we have to understand this formula, that we are going to predict the demand for the next period, which is ft plus 1. We have used here alpha, which is a smoothing constant, to further smoothen out the variations in the demand. dt is the actual demand for the present period. For example, today the month is, let's say, November, you want to predict for December period. So dt will be the demand for November, and ft1 plus ft plus 1 is the forecast for December. You want to do forecast for December. ft is the forecast for November itself. Earlier you must have done forecast for November. So this formula, when we use this formula, it gives you better result. It gives you a better forecast. So alpha is always between 0 and 1. For example, if alpha is equal to 0.2, then if we put these values in the formula, ft plus 1 is equal to 0.20. What is 0.20? It is alpha. Alpha is in the formula. So we have put 0.20 into dt. So alpha into dt plus 1 minus alpha, that is 1 minus 0.20 is 0.80 into ft. So that was there in the formula, ft. So when you put it, so the equation will become like this. But if your alpha is 0, that means smoothing constant is 0, there is no smoothing constant, then ft plus 1 will become 0 into dt plus 1, because 1 minus 0 is 1, into ft So this will be equal to Ft because 0 into dt becomes 0. So your forecast for the next period is the same as the forecast for the previous period. So that means forecast does not reflect any recent data. Let's say if your smoothing constant alpha is equal to 1, then forecast for the next period Ft plus 1 is equal to alpha into d, that is alpha is 1, so 1 into dt plus 1 minus alpha. So 1 minus 1 is 0, so 0 Ft. So 0 Ft becomes 0, so it becomes, and 1 into dt becomes dt. So your forecast for the next period is the same as the demand for the present period. So here we can say that forecast based only on most recent data. So for example, now we have taken this illustration, the months from January to December, and let's say this is the demand which is shown on the slide. So if we want to calculate forecast for the next period, so we'll put in the formulas. So alpha into dt plus 1 minus alpha into forecast. So accordingly we can forecast for the next month. So like this, the demand and for the next periods, when we put in the formulas, and we have taken, if we take alpha is equal to 0.3, these will be the forecast. If we take alpha is 0.5, then the last column will be the forecast. So like this we can calculate the forecast by using these formulas. So exponential smoothing, if we see the curves, this is the actual demand, and this is, if we are using alpha, that is smoothing constant at 0.30, then it is smoothing it out. If we take 0.5, it is further giving more actual. So this is smoothing it out, but it is, the reading is above that, the curve is above the curve of 0.30 alpha. So 0.50 alpha is above 0.30 alpha curve. So what is it is showing? It is showing that it is, the results are more close to the actual demand. So the more alpha you take, the more likely the results are near to the actual demand. So further we can keep on refining it. So then there is another method called adjusted exponential smoothing. So in adjusted exponential smoothing, AF is adjusted forecast for t plus 1 is equal to forecast for t plus 1, which we have calculated earlier, plus t plus 1. What is t over here? So capital T is an exponentially smooth trend factor. So here we have introduced another factor which is called exponentially smoothed trend factor. So here again there is another formula to calculate this t plus 1, that is trend factor. So this is equal to beta is another smoothing constant, into f t plus 1 minus ft plus 1 minus beta into trend for t period. So where t is the last period trend factor and beta is the smoothing constant for the trend. So when we put these values into these adjusted exponential smoothing, further we will see that your result will be more closer to the actual demand. So the formulas become more complicated, but then your results are also more accurate. So here we are trying to show you through this slide, by putting these formulas, we have put the same formulas, and then finally you see what the trend column and you see the adjusted forecast methods, and you will find that they are more closer to the actual demand. So here if we see this curve, this is the actual demand, and now this curve is even much closer to the actual curve because it is based on adjusted trend factor. So this is the adjusted forecast. So there are various mathematical and quantitative methods through which we can forecast. So as we are using more smoothing constants, more adjustable factors, we are getting more accurate results. Further, we can also have some more methods. There is another method called linear trend line. So linear trend line, here we use the basic linear function, which is a basic application of the geometry and basic application of the mathematical function, which is y is equal to a plus bx, where if we draw a graph, so here y you want to calculate, there are two variables x and y. So x is a independent variable, y may be a dependent variable, or y may be an independent variable, x may be a dependent variable. So a is the intercept, so this intercepts on the y-axis. B tells you the slope of the line. X is the time period, and y is the forecast for the demand. Here, for our forecasting purpose, we are taking x as the x-axis as the time period and y-axis as the forecast. So we use these formulas. If we want to calculate these constants, b is equal to sigma xy minus n xy bar divided by sigma x square minus nx square, and a is equal to y minus bx. So where n is the number of periods and x bar is the mean of x values and y is the mean of the y values. So we use these methods also to forecast. For example, let us see this least square example. There are periods 1 to 12, let's say these are 12 months, and this is the respective demand. So you want to calculate that what will be the demand in the next period. So you according to the formula, you multiply x. So x is your period 1 to 12, y is the demand. So you multiply x with y, and then you add all of them. Then you calculate x square. You square x values, and then you calculate the total of all these values. And then simply you have to put these values into the figures. First of all, you have to calculate x bar, which is the mean of x values, mean of y values. B, you simply have to put the value sigma xy is 3867 minus n, total values of n are 12, y bar, x bar, y bar divided by sigma x square, which is 650, minus n, which is 12, x square, which is 6.5 square. So when you calculate, it comes to 1.72 b value. Now the equation was a is equal to y plus bx. So when you put these values, you get, when you know b, you can calculate a. So a is 35.2. So now your linear trend line becomes y is equal to 35.2, which is a plus b. B is 1.72, so a plus bx. So forecast for period 13th. Now you have 12 months. You say January to December. Now 13th month is again January. You want to calculate the demand for the period of January, that is 13th period. So simply you have to put y is equal to 35.2 plus, now x is 13th. So you have to just change the value of the x. So now you get the demand for the 13th period, that is January, which is 57.56 unit. So this, by using this formula, we can calculate very accurate demand forecast, and it may be very near. So in the graph also you are seeing the actual demand versus the linear trend line, which is quite close to the actual demand. So therefore, we can use these methods. Then we can also use seasonal adjustments also. Seasonal adjustments are, there is a regular demand, but according to the seasons, as I said earlier, the seasons may be with respect to the weather season, winter season, summer season. So seasonal adjustment, repetitive increase or decrease in demand, use seasonal factors to adjust forecast. So here the formula is di upon sigma t, that is demand for period I divided by the summation of the demand for the previous periods. So as I said, there are seasons, there are summer seasons, winter seasons, then there are festival seasons. So in any country there are seasons with respect to the weather seasons, with respect to the climate. Then there are seasons with respect to certain festivals. For example, if you talk about country like India, there are festivals, there are marriage seasons, so the demand increase all of a sudden in such kind of festivals. So therefore you can also incorporate a seasonal factor, which is di upon sigma d. So for example, if we see in this slide, let's say you have years demand patterns for year 2022, 2023, 2024. So for first quarter the demand is say 12.6 in 2022, second quarter it is 8.6. So like that, you know, for example, you have got the demands. So what you have done, you have introduced a seasonal factor di upon sigma d. So di is, so you have calculated some di and you have divided it by the total of the demand, which is coming to 148.7. So a seasonal factor has been introduced, and then when you put in the formulas, the same formulas which we used earlier for smoothing constant, so you can predict the demand for say year 2025. So therefore we see that there are various methods of forecasting. There are many other methods also for forecasting. And finally, we also have to see that what has been the forecast error. So there are different methods to calculate those errors. And in the future, when we are doing our forecast, we have to take care to reduce those errors as less as possible. So it's just like, again, I will draw an analogy with the stock market. In stock market, there are funds like index funds, wherein they have to map in mutual funds, they have to map index funds with the actual index like Nifty or Sensex, and then there is a tracking error. So similarly here also in forecasting there could be an errors. So the idea is to find those mathematical models which reduce those errors to the minimum possible, so as less as it's possible. So therefore forecasting is a very important technique. By forecasting, companies can plan their inventories, companies can plan their labor requirements, companies can plan their plant layouts, company can plan their finances. So therefore we will request our audience to study more mathematical models and to practice these models and to do some other numerical problems on these models. So thank you so much.